with the optimization principles for LTE. And in the last part of the chapter, we would also be covering some part related to the basic troubleshooting for LTE networks, like the SINR problems in LTE and throughput problems in LTE. So the target for this chapter is to cover the LTE tuning process. We would see what are the various parameters for LTE, basic parameters for LTE, and various approach to for the tuning of the parameters. And we would also be discussing a little bit about the physical audit and physical configuration audit of the site and the basic physical tuning requirements. We would also be discussing on the radio coverage optimization part of it, and we will be discussing on the issues and troubleshooting of the LTE networks. So if we talk about the overall initial tuning and optimization process for the LTE, we can put it in two ways. One is the field test based tuning or optimization. Another is the radio network statistics and KPI based optimization. So in the first part, we try to gather the field data, and the output of the field data is used for the tuning or optimization for the network, whereas the radio network statistics recovered from the OSS are used for the optimization. The output, if we talk about the field network tuning or the field data collection and analysis, those would be the verified and recommended antenna azimuths and verified and recommended down tilts for the antennas. And there could be other physical configuration changes, like the if we are able to, or if we can do the replacement of the site or relocate the site, reorient the site, we can change the height of antenna if possible. So those could be the set of recommendation which will be clearly available out of the drive test part. Whereas from the KPI analysis or the performance data analysis process, the output would be some recommended parameters and some various features related to the network configuration. So if we discuss basically about the difference between the tuning process and optimization process. In the tuning process, the main activity would be the establishing or acquiring the data related to network performance, mainly using the drive test and the field data collection, to ensure it is possible to drive in the network without dropping the call, so that we are able to set up check the retainability of the call, and to ensure the possible setup calls in the coverage area to ensure the accessibility of the network. So there will be two or three major output which we will be extracting out of the field data collection or the drive test. One part would be the network coverage test, network coverage sampling. Another part would be the network quality sampling. Another part would be the retainability, accessibility, and throughput and performance related parameters. And as a part of network tuning, we also try to analyze and describe the underlying problems related to the design of the network, the various categories of the UEs to take as a data collection, and the overall system level performance. Whereas in the optimization performance, we try to identify and improve the radio network related problems using the statistics, recordings, and various events which are captured with the help of various counters as a part of the performance management system, which could be inbuilt within the OSS or the NMS. We will also try to analyze a lot of data samples, so that we are able to establish the subscriber behavior and the perception of the subscriber in the network. And we can also extract out the traffic growth in the network and analyze the overall traffic growth, so that we can set up the various performance changes in the network. Now let's start with the first is the activity which can be done sitting in the office without even going into the field, is the default parameter audit. So we can do the parameter audit of the networks. What parameters we have decided for the high level configuration of all the sites. So these, since each of the parameters is having very important role in the behavior of a site or cell, so efficient control of the overall network qualities and issues would be decided by the better configuration and combination of the parameters, and those parameters are properly adjusted. Any parameter, if that is configured incorrectly, that can cause a big damage to the network. It can cause a big degradation in the customer satisfaction, and it may also force us to find out the problems in the network. So what we do in the parameter audit is to have some standard parameter set mainly, or some couple of possibilities or flexibilities for some of the parameters could be there, and we just have just design the very simple Excel based macros, and which can compare the data with the default data, and it can give out us the discrepancy in any of the parameter if there is any. So there would be simple Excel sheets containing a lot of details related to site, like the identity of the sites, like the enode B name or location ID, site type, enode B ID, local cell ID, project site ID, etc. Then it will be having some site configuration parameters, like the tracking area code, frequency bands, and then the frequencies for uplink and downlink, the bandwidth configuration, FDD or TDD configuration, the PCI, the PREH route sequence index, the radius of the cell configured, and the signal power. There would be some parameters related to the location of the sites, like longitude, latitude, azimuth, antenna heights, electrical tilt, mechanical tilt, etc. And there would be some parameters related to the core network configuration and identification of the sites. So that could be a set of maybe 100 parameters, and those parameters could be compared easily with some default set of the parameter, and very easy Excel formulas can be used to extract out the discrepancy in the site configuration physically or the logical parameter level. Now, based upon our parameter audit, we have to do the initial tuning, and this is done to make sure the radio networks works well after the network have been built. So it has to be done whenever the new sites are integrated. So within the initial tuning service, we try to verify the radio network design and corresponding network data has been implemented correctly by the implementation teams and these site integration teams. So the prerequisite for the initial tuning would be the cluster plan should be completed. All plant sites are integrated, tested, acceptance testing is done for these, and they should be working condition. There should be no service affecting alarm on any of the sites, and all sites are loaded with the or configured with the radio network design data, and network should not be in commercial service before the initial tuning, so we are able to do lot of optimization or tuning activities without even affecting the service quality to the customer. So we need not to fill so many customer change request forms just for doing the simple activities. Now, as a part of the tuning activity, we have to just first do the preparation for the tuning. We need to first do the project plan, make the project plan, and check what all are the activities we are going to do and how we are going to do these. Then the radio network auditing. Auditing again, those could be two parts. One could be the physical site configuration audit, other could be the logical parameter configuration audit. Then we need to do the drive test route plan so that we are able to do the data collection in the field. And whatever data we have collected, we need to do the post processing, and then collectively, based upon the physical configuration, based upon the logical parameter configuration, and based upon the data collected in the field, we need to analyze collectively, and change proposal report has to be prepared so that we are able to recommend what all changes are required in the network to ensure the optimum performance. And the results of these activities would be the verification of critical items has been done, initial tuning analysis report and the verification report has been done, and presentation of the result to the planning team so that they are ready to accept our change plan and getting their acceptance so that we are able to do it. If you see the major activities as a part of optimization steps, so one is the antenna optimization, that is the one of the most important and most easily could be done. You cannot relocate the site easily, you cannot change various parameter independently for each and every of the sites. So what's the best way? Just do the antenna optimization, do the coverage optimization, quality optimization, and you are able to get the best performance out of your network. So as we know, the antenna would be specific to given frequency band. There will be specific gain to the antenna at various frequencies. There will be specific vertical radiation pattern, a vertical beam width, and specific horizontal beam width would be there for antenna. There are a couple of more parameters like front to back or front to side lobe ratios. So these would be couple of parameters. Now, what are the important terms which will be taking part of the antenna optimization process? These are the beam width, the horizontal beam width of the antenna, which defines the horizontal coverage, and the vertical beam width of the antenna, which also defines the ground coverage as well as the front lobe buildings and various clutter coverage, and tilting of the antenna. Usually in the standard network, the location of the site would be fixed and the orientation grid is also kept fixed for many networks. So in that case, we would not be able to change the azimuth. However, if that is allowed, that could be one of the other aspects of doing the antenna optimization and antenna tuning within our network. So antenna down tilting is one of the very important exercise for directing the radiation within the required area as well as to avoid the interference in the non-required area. There could be two category of the tilts in antenna, as we all know, mechanical tilt or electrical down tilt. In case of the mechanical tilt is nothing but just inclining the overall body of the antenna. So once you incline the front lobe towards the ground, at the same time so you are declining the back lobe of the antenna towards the space. Whereas in case of the electrical down tilt, since you are playing with the dipole area within the antenna, so what you are doing, you are down tilting both the beams, front lobe as well as the back lobe. Which is good or which is better, I mean there is nothing specific studies are there, that's all depends on the what type of clutter and what type of radiation requirements you are having within your cell design. If you see the overall network optimization flow charts, so first the new site on air, that would be the starting point. You can do the single site verification, you can check the functionality of each of the cell whether they are functionally working well, they are connected with the back core network, connected with the backhaul and core network, they are configured within the core network, they are integrated so that we can change the functionality of the site, the basic functionality should be working. Then we need to see whether this is a standalone site or this site is a part of a big cluster. So in case if this site is a part of the big clusters, we need to check if all the sites or at least more than 80% of the sites within the clusters are ready. In that case, if the cluster is not ready, I mean there is no purpose of going for the cluster level optimization. In case all the sites of the cluster are ready, we can go for the cluster level RF optimization, whereas we are able to see, analyze and do the performance improvement on the group of sites known as a cluster or subcluster. Then we do the service test and parameter optimization based upon our activities like the physical configuration audit, parameter configuration audit, and the site field data collection via drive test. And if we see after doing the required optimization, if all the agreed KPIs are already within the range and they are met, perfectly fine, the process ends here. And in case if some of the KPIs are not met, we can again do the performance of the network test and network optimization. So first we need to establish the optimization objectives. We need to do the partition of the cluster, define the drive test routes within the clusters, and we need to prepare the tools and materials. Same time, we need to do the data collection. We also need to do the indoor measurements and do the checking of the E-node V configuration data. If all the KPIs are already met, need not to do any additional activities. If all the KPIs are not met, we need to do the problem analysis that could be related to coverage, that could be related to handover, that could be related to various other factors with probable factors, and we need to do the recommend the changes for the recovery of all these problems within the network. So we can do the engineering parameter adjustment or physical parameter adjustment or the neighbor cell parameter adjustments. So what all methods are there available for the optimization? There are various strategies or various parts where we can do the changes in the network which can help us to give the optimum performance. You can try to adjust the tilts, you can try to adjust the azimuth, you can try to adjust the parameter handover related parameter adjustment, you can try to adjust some of the features, you can try to change the antenna heights, or you can try to change the power adjustments. So again depends, I mean, what all are the most important parameters which can be changed, parameters or configuration which can be changed easily without affecting the overall network strategy, and still we are able to get the good smooth coverage within the network. So the optimization parameters mainly based upon the coverage RSRP, that could be based upon SINR, the quality, and that could be based upon the retainability or Handover success rate. Now let's see the classification of various coverage problems, which is represented by RSRP in LT, reference signal received power. So there could be problems like the weak coverage and coverage halts. So there could be no coverage at some of the places, there could be very poor coverage at some of the places. So our requirement is the continuous coverage should be there within the coverage area of the cluster, so that we need to ensure. The another category of the problem could be cross coverage. The actual coverage must be due to the plant site at any point. So suppose we are doing referring to one particular point on the ground or any coverage area, so there the coverage should be coming from the nearest dominated site only. There should not be coverage coming from the isolated areas. Then imbalance between uplink and downlink. So it also depends, like the uplink link budget and downlink link budget should be cautiously chosen in such a way so that we are not having the imbalance. And lack of dominant cell. Each cell must have a dominant coverage area. The coverage area of various cells should not be much overlapping. So now let's see the factors which are affecting the coverage. In the downlink, the EIRP of the cell, that itself affects the coverage. So we have to select the EIRP. Usually it is standard across all the cells. So we have to decide whether we are using 20 watt, 40 watt or 60 watt. What is the EIRP? Total transmit power, the combining loss, if the feeder line system we are using, the path loss in the air interface due to various clutters, the frequency band of implementation, the distance between the receive point and the E node B, the scenarios, urban and suburban areas, and the various category of the terrains defined as a part of the channel propagation model. The gain of various antennas, the height of antennas, various parameters related to antenna like the antenna pattern, front to back lobe ratio and gain, etc. The tilt view configured and the azimuth view configured for the antenna. Whereas in case of the uplink, the most important factors which will be affecting the coverage would be the E node B receiver sensitivity, the antenna diversity gain, the transmit power capabilities of the UE, and propagation loss in the uplink radio signal. Usually it's same for the uplink and downlink, but if still we need to see the overall geographical distribution of the UEs and take consideration. And impact of the tower mounted amplifiers on the uplink. So in the uplink, tower mounted amplifiers usually give us some gain in the uplink direction, same time they have given some losses in the downlink direction, so we need to check both of them appropriately. So in case of the weak coverage, this quality of the cell is poor, then the optimization baseline in the area, and UE will not be able to register within the coverage area, or in case it is registered, we may not be able to support all the different. In the case of the coverage hole, there is no coverage or coverage level, no coverage at all, or there could be coverage level which is very low in the area. So the receive level of the UE is less than the QRX level minimum. So in that case, we will not be able to latch onto the cell. So in that case, the UE will be disconnected from the network, and UE can be connect once UE is moving into the weak coverage. There could be handovers could be triggered, and sometimes it could be successful, sometimes it could be failure also. So a lot of call drops can happen due to this. So what are the various steps to resolve the weak coverage problem? First, they analyze the geographical environment and check the receive level of the adjacent T node Bs. Analyze the ERP of each sector based on the parameter configuration. Increase the pilot power or adjust the antenna azimuths at tilt so that we are focusing on the required area. In case if we are not able to achieve with the help of the antenna configuration and parameter configuration, we need to deploy the new E node B in case if it is needed. So capacity node B could be required, or you can try to achieve little bit larger coverage overlapping between two node Bs so that we have the moderate handover areas and sufficient overlapping is available. And or we can, if in case we are still unable to achieve the coverage targets, we can use the RRUs and or the indoor distribution system, distributed antenna system, or leaky feeders or directional antennas to target a particular area for the coverage and to ensure the better quality in the network. So by using the scanner in the unloaded networks, we can do the RSRP drive test and we can try to find out the weak coverage area. Lack of dominating cell it happens because the serving cell level would be almost same as per the level of the neighboring cells, and receive levels are much closer from all of the cells. So none of the cell is a very is a potential cell for the latch on, and it will also reduce the SINR in the network. So this is also one of the problem in the network. So how to resolve the problems with the lack of dominating cell? First is that determine the cell covering an area without dominating cell. First to identify the areas with the help of drive test probably, and try to adjust the antenna tilts and azimuth to increase the coverage by a cell with a strong cell and decrease the coverage of other cells. Now here we can also try to do some adjustment of the logical parameters so that we are able to get the better coverage. Cross coverage in case the one of the node B radiates in the area which is planned for other node B. So that could be mainly related to the high low down tilt or the high height of the antennas. In that case, it can the one of the antenna can radiate in the far flung area from the point where the site is actually located. That could be one of the disaster in case of the network performance. Unwanted neighbor coverage could be there, and sometimes if that neighbor is already configured or automatic neighbor relation is enabled in the network, sometimes it may be considered as a potential neighbor for handover. The handover would be triggered and in turn the call may be dropped or call may not be through for much more time. Now how to avoid the cross coverage problem? First, the try to adjust the antenna azimuths in the direction of the main lobe where required, and we should also ensure that the main lobe of the antenna doesn't face an open area where the coverage may go to hundreds of meters or couple of kilometers. So we should avoid this for the excessive coverage of the electromagnetic waves. We can also adjust the antenna tilts. We can put more down tilts so that the coverage doesn't go to the far flung areas, and we can decide whether we want to do electrical tilt or mechanical tilt. Same times, if it is possible, we can also try to decrease the antenna height for the sides or reduce the transmit power for the antenna. Imbalance between uplink and downlink, that is also one of the biggest problems in the radio network performance, although it's much harder to establish as compared to other coverage problems which are mainly related to downlink. So here the downlink quality would be very good, downlink coverage would be very good. However, still we would not be able to meet up the target BLR requirements. So in that case, we will need to do some checks in the networks and find out the reason for the uplink and downlink coverage, and we need to adjust our planning parameters for link project. So in case no performance data is available, we need to put the one particular UE on the trace and doing the drive test and find out what could be the reason for uplink downlink balance. Or if the uplink interference is very high, in that case the uplink link budget will be shrink to somewhat low. So in that case, we need to see the overall parameter configuration or the performance of the network device like the BTS. The SINR problems, the poor SINR problems in the network, that could be related due to the poor frequency plan, which is not a case in that. In case of the LTS, it is a single frequency network. It could be due to the poor cell layout, lot of overlapping of the main lobes of various antennas that can be configured with the proper grid planning of the antennas and cells. It could be due to the poor site selection and poor antenna height, that could be recovered with the help of the appropriate site selection and the appropriate height of the antenna. or in the last it could be with the help of the doing the changes of antenna azimuths and antenna tilts. We should be able to achieve the better SINR as compared to the poor radio configuration. So the first step should be optimize the frequencies. That's not the case here because we are having the single frequency networks. Adjusting the antenna system so that the overall prediction plot is much proper and the proper dominant sectors are available within the network. Adding the dominant coverage, they increase the power of cell and decrease the power of other cell at various places wherever the lot of interference is there, or adjusting the power so that the overall system prediction system coverage should be ensured. I mean, it's as a matter of fact. I mean, with the help of the antenna azimuths and antenna tilt, you can do the much of the optimization activities in the network, and you can ensure the better performance. This is one of the example, whereas at typically very high, very low antenna tilts and different azimuths, we are able to see the coverage at various part of the network. However, still the quality is very poor. Whereas once you do the tilt optimization, you do the appropriate tilt and azimuth changes for the various sectors, you are able to achieve very good level of SINR in the distribution of the coverage area. Now the analysis of the handover success rate problems. So poor handovers could be related to the validity of the neighbor and neighbor relations. It could be due to the lot of interference problems in the mainly in uplink bands, and it could be due to the coverage problems as we have discussed. So neighbor cell optimization must be performed so that UEs in idle or connected mode can be appropriately perform the reselection to or the handed over to other optimum dominant serving cells, and this helps to achieve the continuous coverage and the seamless service within the network. And it should be designed in such a way so that there are no delayed handovers are not delayed, the handovers are not having ping pong, and non-logical handovers are not there. So we first need to check the handover validity to obtain the source and target cells using the drive test or the any other neighbor planning software. Checking the interference in both source and target cells, so unnecessary handover should not be triggered to the cell which is already interfered. Checking the coverage, so coverage footprint should be much smoother as we already done in the previous slides. Check handover based upon RSRP measured in the UE drive test, so we can check whether there was a possibility of handover which could not taken place, and we can use this analysis to define the new neighbors appropriately. Now the throughput troubleshooting, throughput reasons could be due to the low throughput, could be due to the poor BLER or the poor CQI reporting parameters. It could be due to downlink interference, MIMO parameters and MIMO features, other features like the VSW or backhaul, low demand within the network or scheduler limitation. So first we need to identify the cell with the low throughput, identify the downlink interference, and see the CQI values and CQI reporting, and see if the CQI reporting is proper and what are the average CQIs reported by various UEs in the cell, and accordingly we have to see whether it is due to the downlink interference or BLER values. We have to check the BLER, average BLER, and average BLER should be within the target range of 10%. So accordingly, we can have the optimum balance between the BLER and the retransmissions. It could also be based upon some of the throughput improvement features like the MIMO. So we have to identify the transmission mode within our network based upon the feature implementation. So it could be no MIMO, it could be the open loop transmit diversity, or it could be closed loop spatial multiplexing, or it could be dynamic closed loop spatial multiplexing. The low throughput could be due to the low demand also. Probably there may not be a sufficient number of subscribers or a specific type of the UEs which can actually extract the high throughput from the network. So that would also be one of the cause to force low demand within our cell or within our network. Various scheduler features also affects the various features. Scheduler features also affect the overall throughputs like the round robin round robin scheduler is one which will be giving the better average throughput, but it could be the reducing the overall cell throughput. Or CQI reporting parameters also affects the periodicity of the CQI and then the overall implementation of the appropriate modulation coding scheme that will be affecting the throughput. And some the other reasons could also be there for the poor throughput, like VSWR report or the high values of VSWR or the improper backhaul capacity. Those could also be the reasons for the low throughput. So this way we complete one basic analysis of the how we can improve the LTE throughput and how we can try to ensure the optimum performance of the network as a part of the initial launch of the network. So I believe this investment of your time would be useful to you, and we should be able to have the better performance within our LTE networks and